Hello guys, this is Alan Paul, UR16CS006, and today we're going to do our seventh experiment in the Common System Software and Compiler Lab, which is uh, to design a predictive parser. So the aim of the program is to write a program in C to pass a given string, using non-recursive predictive parsing for a given grammar. So, recursive descent is a top-down parsing technique that constructs the parse tree from the and and the input is read from left to right. So, we construct in recursive descent, we construct the parsing tree from the top, and the result is read from left to right. It uses procedures for every terminal and non-terminal entity. So, we have different for each terminal and non-terminal, we have different procedures, and the parsing technique recursively passes the input to make a parse tree. So in we have then we have the grammar associated with it cannot avoid backtracking. So we cannot avoid backtracking in this product predictive parser. This parsing technique is regarded recursive as it uses context-free grammar, which is recursive. So as the this as predictive parser uses context-free grammar, we can say that we can say that it can also be regarded as a recursive grammar as recursive because context-free grammar is recursive in nature. So here we have seven programs. So we have the necessary input Java files. Then we have this class called array stack. Then we have the protected character array, and then we have protected int, which is top int integer entities, that is top and size. Then we have the public array stack, which is then we are defining this size of the stack as 20, and new character size, and then array is equal to new char, that is the size. So the size entered will be 20, and then top is equal to -1. So every time when there is no entity in the stack, the position of the pointer will be at -1. So as soon as something is entered, something is entered or pushed into the stack, the position will go to 1 or 0. Then we have the public void push character I, which is used to push if top plus 1 is less than or equal to size, is greater than or equal to size, then we'll throw new index out of bounds exceptions. If the top is not at -1, we'll throw an exception that index is out of bounds. If top plus 1 is less than size, then we'll add it to the array, that is array plus top equal to I. And then we have the pop function, which is to pop the element out of the array. Then we have the public void display, which is to display the stack. Then in the main class, we have the throw exception string transition equal to new string. We have the throw exceptions. And then we'll have the int entities, that is alpha set and state set, array list string alphabet and array list string alpha. Then we are defining the buffered reader BR to new buffered reader when we'll take the new input file, that is system.in. So then we'll ask the user to enter the number of terminals, and to enter the number of non-terminals, the starting non-terminal of the grammar, and all the terminals simultaneously. Then we'll ask the user to enter all the non-terminals simultaneously, and we'll keep on adding it into the array. Then we'll just for the in the transition table input, we'll for epsilon we'll use at, and then we'll ask user to enter the transition table. As we will keep on entering the elements into the transition table until the input is full, and then we'll ask the user to give the input that is needed to the parser, and then we'll also ask the user to end the input with dollar and hash character. Then we have the we'll check the stack. We have the input and the output will check fully, and then if the string is accepted, we'll say the string is accepted, and if not, we'll just say that the given string is not acceptable. And then once the string is accepted, we'll check, we'll do the passing, and then if the passing completes, it will print that passing is completed successfully, and then we'll ask the user to show, we'll ask the user if he wants to continue or not. So here we have already run the program. We have the number of terminals as 6, the number of non-terminals as 5. The starting non-terminal in the grammar is E. The terminals, all the terminals I entered simultaneously are A plus multiply, open bracket, close bracket, and dollar, and the all non-terminals are E, A, T, B, F. Then we have the transition table for in which the first element is E, gives E tends to TA, then null, null, E tends to TA again, null, null. Then we have the second transition table, which is the enter into the second line of column or row of the transition, which is null, A tends to plus TA, null, null, A tends to epsilon, A tends to epsilon. And the next transition line, which is T tends to FB, null, null, T tends to FB, again two more nulls, null statements. And then we have the transition table for F tends to A, null, null, F tends to open, F tends to E in brackets, null, null. Again, the next one, E tends to TA, null, null, E tends to TA, null, null. Then we'll have, these are the inputs that we entered. Then we are asking the user to enter the input and to end the input with the dollar and hash character. So this is the stack input. So we can see this is being done, and thus the program is completed successfully. Once the passing is completed, as the passing is completed, the program is completed successfully.